All right, so we're going to go over 2006 free response number one. Remember, you do get to use a calculator on that. This one, you're definitely going to need it. Okay, so part A, all you're going to do is find region R that's bounded by y equals the natural log of x and y equals x minus 2. Okay, so on my graph, okay, I would even label this one as y1 because that's what I'm going to type it into my calculator as, the natural log of x. Okay, so the reason I like to label each one of these is so I remember which one I have where on my calculator.
Okay.
Alright, so really all I'm going to do is I already found my intersection points. Okay, I labeled this one A, B. I wrote down all the decimals for A and all the decimals for B. And I did the same thing for this intersection point. I labeled it CD. Okay, and I said C is going to be all these decimal points. And D, make sure you remember, is going to be this negative value here.
And definitely label both the x and y because you might need both. Even if you don't, it's not bad to have it at the beginning, right? This is the window, you guys, that I set on my calculator because it looked like they didn't give us any kind of x or y tick marks, but maybe I want a little bit of space to the left instead of starting right at 0 for x min and negative 1. And I went to 5 thinking, well, it's probably not like too crazy. It doesn't look like a big portion of the graph going by ones. And then I did negative 5 to 5 going by ones. So when I hit my fifth function button, there's a graph which looks like the graph that they already have on there where you can see the region R that's bounded by that curve and that diagonal line.
Okay, so we're going to find this region R. I think the easiest way to do it is top minus bottom. In theory, you could do right minus left. All right, but let's just stick to top minus bottom on this one. So all I got to do is integrate. Okay, I already labeled points. Okay, I'm going to want to integrate from C to A. Okay, you don't need to actually write out all those decimals in this case because you labeled it already. Okay, and then I want to do top minus bottom. Now in my calculator, what I'd probably do is y1 minus y2, but we can't label using calculator notation for our work. Okay, so I cannot use y1 and y2. What I'm going to have to actually do is natural log of x minus, and make sure I subtract all of this, x minus 2 dx. Okay, I would put this in brackets as well, and that's really about all you're going to need to do on this problem. So when you type this all into your calculator, you're going to get an answer of...
So when you're writing it for the exam, you can use those letters, right? So the letters that Hernie used were A and C, but you got to type them in. When I'm trying to make that there, that's maybe a little bit better. And there's my y1 minus y2, and then I filled in the x on the end. And you're just going to math 9 it. And I got approximately 1.949.
That's what I got. All right, so guys, that's really all the work you need to show on part A. Okay, you can even just call this A and C as long as you label it A and C were. That will get you full points. Okay. On part B, we need to find the volume of R rotated around the line y equals negative 3. Okay, so I've really got this line down here somewhere at negative 3. Okay, and I'm going to rotate around that. So if you remember, we're going to need to do pi. We're going to integrate, and normally it would be like big R squared minus little r squared. Okay, so since I'm rotating kind of vertically here, my slices would be vertical. So I want to integrate this with respect to x. Now I really shouldn't call this big R squared because I already have R defined here, but it's not that big of a deal. Okay, so to figure out what big R is going to be, it's going to be this distance. Okay? Well, that distance really is going to be my equation. Remember, my equation is the distance from the axis to my curve, and I'm adding 3 onto that. Okay? It gets weird to think about when you're over here and it gets negative, so I would just compare it when it's positive values. Okay, so what I'm going to have here is pi. big R squared is going to be my top curve, which is the natural log of x. I'm adding 3 to that, and that's what I'm going to be squaring. Okay? My little r is going to be this bottom curve. So this bottom curve is actually just going to be x minus 2. And I'm adding 3 to that. So remember, x minus 2 is the distance from my axis to my curve. Okay, but I will always want to be adding 3 to it. Another way to think about it is really top minus bottom, where I have x minus 2 and my bottom line is going to be a negative 3, so x minus 2 minus negative 3. So x minus 2 minus negative 3, I'm really just adding 3 to it. Squared. Remember, it's going to be big R squared minus little r squared. Okay, we're integrating with respect to x, so that means my boundaries need to be in terms of x. So this is going to be from C to A. Okay, you guys don't need to simplify this at all. You can leave it as x minus 2 plus 3. Then you just type it into your calculator.
Which kind of gets messy. So you have the pi at the beginning. Then I did a multiplication sign. You don't have to if you squash together. With Math 9, it knows to multiply. There's our retyping all the digits so we don't have intermediate rounding. You have to have extra parentheses to say y1, because that's where the natural log of x is stored, plus 3. Then close them, that whole thing squared. So like the beginning parentheses are the one the calculator defaults in there. But then you have to add the next set, minus another set, y2 plus 3, close it, square it. It is okay, I've asked on AP before, because I always tell my kids it's from the center of the circle to the edge. So if you did negative 3, let's say on little r, minus the curve x minus 2, you would have to subtract the whole thing or write minus, and then this would be your y2 on your calculator. It's okay because when you square it, it still goes to a positive distance. But the way that Hernie's showing it is better. It's that idea of top minus bottom, so the distance is positive. And then there's a squared. And then the dx on the end. And, dun-da-la, it thinks for a minute. I got, Mr. Hernie, 34.199.
That's what I got. All right, so 34.199. That'll bring us to part C then. Write but do not evaluate. So guys, you don't actually have to get an answer for this. All you got to do is set up the problem on how you would find it. Okay? So now we're going to rotate around the y-axis. So I got to be thinking right, okay, and then minus left. All right, hopefully that makes sense here. So that means that we need to be in terms of y. So before I go any further, I'm going to do pi. We're going to integrate with respect to y. It means my boundaries now need to be in terms of y. All right. So that means I'm going to integrate from d to b. Okay, and then big R squared is going to be my right. So my right is just going to be my equation here, okay? I'm not adding anything onto it or subtracting anything from it. My right equation was y2, which was x minus 2. But remember, if we need to be in terms of y, this is going to be x equals y plus 2 now. So it's going to be a y plus 2 all squared. Minus our little r. Our little r is going to be this natural log of x curve. But we need to be in terms of y, so I need to solve this for x. So we're going to exponentiate, and we get e to the y is going to equal x.
Woo.
So this is going to be e to the y all squared. And that will get you your full points. Okay, you don't actually have to figure out what this is.
And both of these, you guys remember, are washers because there's space left out. So that's why we're using that area of the big circle, pi big R squared, minus area of the small circle, pi little r squared. Because if there's space left out, right, it's a washer instead of a disk.
Alright, so as far as the points go, guys, they're going to be equally distributed. You get 3 points in A, 3 points in B, 3 points in C. So for part A, you get 1 point for having your correct boundaries. Okay, from C to A. You're going to get 1 point for your integrand, which you're going to be integrating natural log of x minus 2. And then you get 1 point for your answer.
If you didn't have the parentheses here around the x minus 2, you would lose this point.
Alright, on part B, you're going to get 2 points for your integrand. So that means you have to have all of this. And you're going to get 1 point if you have your constant of pi, if you have your limits or your boundaries correct, and your answer. So you need all 3 of these to get that point.
Woo!
But you get 2 points for having the correct integrand. On part C, you're going to get, let me double check here. You're going to get 2 points for your integrand, and you're going to get 1 point for having your correct boundaries and
The pi.
the pi.
So when they say on the rubric integrand, that just means the part to the right of the integral symbol. And since these are 2, sometimes like I know that they would give you 1 out of 2. For instance, if you had them backwards, but you knew that they were both squared, you'd probably get 1 out of 2. You could simplify this to x plus 1. That doesn't matter. That's equivalent to this. I would leave it the way Hernie did because that makes more sense with how we do washers. Same thing here. If you have these backwards, but you still squared them, you probably get 1 out of 2. If you squared the whole thing, but had each part with its own parentheses and subtracted, you might get 1 out of 2. It kind of depends on how like grievous the mistake is, if they'll give you the 1 out of 2. But that's what integrand means, just the part behind the integral symbol. If it says integral, it means the boundaries and all of this have to be correct. So they're kind of like taking the boundaries out of play, because if you don't have the boundaries right, your answer's wrong, and that would come from the answer point.
Alright, that's it.